Good evening, dear students.
Yes, ma'am.
Okay, so we are going to start with the new topic today. So the new topic which we are going to start is electrochemistry. So already in our ACE classes, we have seen in detail about electrochemistry, right? So what do you mean by electrochemistry? Yes, what is electrochemistry? It is a study, okay, it is a study or it is a branch of chemistry which deals with what happens here. So there is a production of electricity, right? So there is due to electrolysis, so electrolysis takes place and there is a production of electricity, okay, through a spontaneous chemical reactions. So chemical reactions, and what we are making use of, we are making use of electrical energy here, okay, we are making use of electrical energy to bring out this chemical transformations, okay. So already in the electrochemistry we have studied the different concept, okay. So the students who have not okay, who have not seen the ACE videos, you can just go through the ACE videos. There we have completed the complete notes on electrochemistry, okay, we have studied in detail there. So in these sessions, we are going to solve the questions. Okay, we are going to solve CET questions. Okay, so we are mainly focusing here on the questions. So now I'm not going to tell you going to stress on the points. Okay, so based on whatever things we have discussed in our ACE classes. So let us start with the questions. So I have taken few questions, important questions. Okay, so let us start. So this is the first question. Which of the following electrolytic solutions has the least specific conductance? Which of the following electrolytic solution has the least specific conductance? A, 2, normal. Okay, N is what? Normality. So normal. B, 0.002 normal. C, 0.02 normal. And D, 0.2 normal. Yes. So which is the least specific conductance? What do you mean by specific conductance now? Yes, what do you mean by specific conductance, students? So we have studied different concepts in this chapter: galvanic cell, electrochemical cells, electrode potential, okay, then reduction potentials. Then we have studied the measurements of electrode potential. So these all important concepts we have studied. Nernst equation we have studied. Then equilibrium constant, right? Then different conductivity solutions we have studied, polar conductivity, and also based on that, okay. Uh, can you tell me what is specific conductance? We have studied specific resistance, okay, everything. So can anybody tell me what is specific conductance? Yeah. Okay, Lubna has answered directly B. Okay, her answer is B. What about others? What about others? Yes, what is conductance? I've asked you. So the question is, which of the following electrolytic solutions has the least specific conductance? Okay. Now, what is conductance? Conductance is nothing but the flow of current. Okay, flow of current through any liquid solution maybe. Okay. Now, what do you mean by specific conductance? Specific conductance means what? Specific conductance means when the that is a conductance of an electrolyte, okay, when the distance between the electrolyte, right, is what? So, so between the distance of 1 centimeter, right? So here they have asked among the following four, which is the least specific conductance. Okay, which is the least specific conductance. So here, yes, only one student have answered. So how the specific conductance varies? Okay, they have asked. Sanjeevni has answered as B. Okay, let us see then. So specific conductance of any electrolytic solution. Okay, when we are considering the specific conductance of any electrolytic solution, how it varies with the concentration of electrolyte. Okay, we know what is electrolyte. Okay, so how it varies with the concentration of electrolyte. So, if the specific conductance, if you see specific conductance, okay, if specific conductance, what happens if it increases, okay, it then what increase in concentration. There will be decrease in concentration, okay, or increase in dilution. So, how is your specific conductance related? It is related, it varies with the concentration of electrolyte. So if the specific conductance of an electrolyte, if it increases with the decrease in concentration, okay, specific conductance of the electrolyte, it increases with that is the electrolyte increases with the decrease in concentration or increase in dilution. So if your electrolytic solution, okay, if it has a concentration of 2 normal, okay, it has the least specific conductance. So 2 normal. So if the specific conductance, okay, so this is the least specific. So which of the following electrolytic solution has the least specific conductance is A. Okay, because specific conductance increases with the decrease in concentration or increase in dilution. So option number A is the correct answer. Okay, option number A. So here, what we can see here, the electrolytic solution. Okay, here, if the electrolytic solution is of concentration 2 normal, okay, so it will have the least specific conductance because this you have to keep in mind. Okay, so specific conductance increases with decrease in concentration or increase in dilution. So option number A is the answer. Option number A is the answer. Okay, so this is about the specific conductance. Next question. Yes, Sri Varuni has answered it A. Very good. Let us go for the next one. The standard electrode potential for the half cell reactions are, okay. So there are two, we know what are half cell, okay. Half cell reaction, right hand side, left hand side, at cathode, at anode. So these are the half cell reactions, okay. At cathode is one half cell, at anode is another half cell reaction. So here two half cell reactions are given. First one is Zn plus 2 electrons giving you Zn. Okay, E naught of that is electrode potential of that cell is given as minus 0.76 volts. And the second half cell is Fe plus 2 electron giving you Fe. The E naught of that cell is also given as minus 0.44 volt. Okay. Now here the EMF of the cell reaction is. So the EMF of the cell reaction, what it is? Okay. That is Fe plus 2 plus Zn. Okay, it is plus Zn giving you Zn plus 2 plus Fe is. So Fe, so this is the half cell. Okay, so Zn plus 2 electron giving you Zn and Fe plus 2 electron giving you Fe. So these are the two cell reaction and the half cell is Fe plus 2 plus Zn giving you Zn plus 2 plus Fe. Okay, so you have to tell the electrode potential. How you are going to calculate the electrode potential, students? Okay, so the cell reaction is given here. Okay, Sri Varuni has answered it as C. Lubna has answered it as C. What about others? Others also please try. I'll tell you the. So when you see this reaction, okay, when you see the complete cell reaction, EMF of the cell reaction, here when you see the complete cell reaction, what you can see that zinc, okay, zinc is converted to Zn plus 2. Means what it is happening? So zinc is oxidized. Okay, oxidized means what? Oxidized means it is losing electrons. So zinc is oxidized to Zn plus 2. Okay, zinc is oxidized to Zn plus 2. And Fe plus 2 is what? It is reduced. Okay, Fe plus 2 is reduced to Fe. Means there is a gain of electrons. Okay, in Fe, in the case of Fe, there is gain of electrons. So when complete cell reaction is given, so based on this complete reaction, you can tell one is undergoing oxidation, another is going reduction. Okay, one is getting oxidized, another is getting reduced. So by seeing the cell reaction, so your zinc is getting oxidized to Zn plus 2 and your Fe plus 2 is been reduced. Okay, so if I want to write the cell reaction, if I want to write the cell reaction of this particular complete cell, okay, if I want to represent it, so it will be zinc dipped in Zn plus 2. I hope you know how to write the cell, how to represent the cell. So zinc rod, okay, dipped in zinc sulfate solution, Zn plus 2. Okay, this is aqueous. Then this double lines, what does it, double lines represent? Your salt bridge. Okay, salt bridge. And then Fe plus 2, Fe plus 2 aqueous. Okay, and dipped in Fe rod. This is the complete cell representation. So this is the cell representation of this particular cell. Now, if I want to calculate the EMF now, EMF of the cell is calculated as what? E naught of cell is equals to E right cell minus E of left. Right. Now, what is E right? Right is which is undergoing this reaction. So this is our E right, right? E right. And this is our E left. So write the take the EMF of this cell. E naught of the cell is given. E right is which? Fe. Fe is minus 0.44 minus E naught of left cell is minus 0.76. Find out the answer. I have told you how to do. Sanjeevni has answered it as B. Yes. Others? I have told you how to solve. Okay. So how to find the EMF of the cell. So I have told you how to write the cell representation. So only by this data, okay, by the half cell reaction and E naught of the cell, we have found out the cell, complete cell representation we have done. Then we E naught of the cell we have to find out. Okay, baby has answered it as C. Okay, simple calculation minus 0.44 minus this. So it will be 0.76 minus 0.44. So what is the answer? I'm getting at 0.32 volts. Are you getting the same? 0.32 plus 0.32 volts. Plus, option number C is the answer. Option number C is the
Yes,
answer.
ma'am.
Yes, okay. Lubna has also got it. Yes, very good. So whoever has told it as option number C, option number C is the correct answer. Okay. So like this, similar type of question. Okay, different half cell reactions will be given. You have to find out the E naught of the cell, EMF of the cell. Okay. So I hope this is clear. Okay, similar type of questions, only the cell reactions will be different. Okay. I hope it is clear. Let us go for the next one.
Excuse me, ma'am.
Yes.
Ma'am, the previous question answer is 2n itself, ma'am.
Yes. Yes, 2n it is. I told you the
First
spare.
question, ma'am.
Yeah. It is 2n. Because what we have discussed here about the specific conductance, right? And when we are talking about specific conductance, what did I say? That specific conductance of electrolytic solution, it varies with the concentration of electrolyte. So if the specific conductance of any electrolyte, if it increases, okay, how it increases? It increases with decrease in concentration. As the concentration decreases, specific conductance increases. Now here what they have asked the least specific conductance. Okay, for the least specific conductance, what should be the electrolytic concentration? It should be more. Okay, so it is option number A. Okay, option number A. So how does specific conductance of electrolytic solution increases? It increases with decreasing concentration or increase in dilution. So for any electrolytic solution, okay, if the concentration is too normal, then it is having the least specific conductance. So they have asked the least specific conductance. So these things you have to keep in mind. Understood? So option number A is the right answer. I hope the doubt are clear. Okay, let us go for the next question. In the electrolysis of acidulated water, it is desired to obtain 1.12 cc of hydrogen per second under STP. What is STP? Standard temperature pressure condition. The current to be passed is A, 9.65 ampere, B, 19.3 ampere, C, 5 ampere, and D 1.93 ampere. So in the electrolysis of acidulated water, okay, in the electrolysis of acidulated water, what do you mean by acidulated water? Electrolysis means, so in your glass beaker, water is there, okay, and H plus ions are added. Acidulated means acid, okay, and electrolysis is done. Electrolysis means what? Electric current is passed to that. So it is desired to obtain 1.12 cc of hydrogen per second. So from this electrolysis of water, what they are doing, they are removing hydrogen. So at per second condition, that it is condition is that 1.12 cc or ml of hydrogen is to be removed. Okay. So how much amount of current has to be passed? Okay, so A 9.65, B 19.3A, that is ampere. A is nothing but your ampere. So these are the different current units to be passed. Now, how you are going to solve this particular question? Okay, so first you have to calculate the number of moles. First, you have to calculate what? The number of moles. Okay. So number of moles is what? Given weight upon the molecular weight. Right. Now, given weight is what? The number of moles of hydrogen. Okay. So it is 1.12 cc. Okay. And what is the standard at STP? It is the volume taken is 22,400. Okay. So the number of moles of hydrogen, so given weight is 1.12 and at the standard volume, okay, the standard volume is 22,400. So the number of gram equivalent. So the number of equivalent of hydrogen. So what is the number of equivalent of hydrogen? So that is 1.12 into 2. Okay. So that is hydrogen. Hydrogen is H2. So 2 atoms per this. Okay. So it is, we are multiplying by 2 and 22,400. So just see how much you will get. 1.12 into 2. 1.12 into 2. 0.12 into 2 divided by 22,400. So I'm getting as 0.0001. That is 10 raised to 1, 2, 3, 4 minus 4. Okay, 10 raised to minus 4. So the number of Faraday. So how many Faradays are required? So the number of Faradays current. Okay, it is required is 10 raised to minus 4. Okay, then how much current should be passed? So current to be passed in 1 second. Okay, passed in 1 second is 96,500 into 10 raised to minus 4. Okay, so 96,500 into 10 raised to 4, that is 0.0001 is 9.65 ampere. So this much current has to be passed, that is 9.65. So option number A. Option number A. So what we have done here, first we have calculated the number of moles. Okay, we have calculated the number of moles. So number of moles of hydrogen is equals to 1.12 divided by the standard volume of hydrogen. Okay, at STP condition, the condition is under STP. So we have to calculate at standard volume, that is 22,400. Now for number of equivalent of hydrogen, how it is calculated? Gram equivalent is 22. Okay, that is hydrogen H2. So H2 means you have to multiply it by 2. So 1.12 into 2 divided by 22,400. So the number of Faradays required will be 10 raised to minus 4. So current which is passed for this is Faraday. Okay, we are calculating. We are multiplying it by Faraday. That is 96,500 into 10 raised to minus 4. That is the current to be passed per second is 9.65. So at if you pass 9.65 ampere of current, okay, per second, then you are going to get 1.12 ml of hydrogen per second at standard temperature and pressure condition. Okay, so option number A is the answer. I hope it is clear. Okay. Let us go for the next one. The one which decreases with dilution is. So the one which decreases with dilution is A, conductance, B, specific conductance, C, equivalent conductance, D, molar conductance. So please study the definitions properly, each of them, each conductance, it is different. Okay, so please study first the definitions and then you see how it whether it increases or decreases with dilution. Okay, so then apply the question. The one which decreases with dilution is, okay, Sanjeevni has answered as C, Baby has answered as B, Shri Varuni has answered as B. Okay, so the answer here is what? So when you do on dilution, okay, on dilution, what will happen? The specific conductance will decrease. Okay, just now we have seen that. Yes, option number B is the correct. So on dilution, what will happen? Number of ions will decrease. Okay, it will decrease per unit volume. Per unit volume. Okay, so because of that, the specific conductance also decreases. So option number B. So the one which decreases with dilution is specific conductance. Okay. Option number B is correct. Very good. Let us go for the next one. 9.65 coulombs of electric current is passed through fused anhydrous magnesium chloride. Anhydrous means what? Anhydrous magnesium chloride. Anhydrous magnesium chloride. Anhydrous means there is no water molecule associated. No water
It is
molecule.
dry, ma'am.
Yes, yes, it is dry. Okay, that is it. No water molecule is associated. Okay, it is dry powder. So anhydrous, remember, okay, in the words like this, anhydrous. What do you mean by anhydrous? Means there is no water molecule, any water molecule associated with that. So 9.65 coulombs of electric current is passed through fused anhydrous magnesium chloride. The magnesium metal thus obtained is completely converted into a Grignard reagent. Now, what is a Grignard reagent? Grignard reagent is a organometallic reagent. Okay, organometallic reagent. How do you represent it or your organometallic reagent? That is your Grignard RMGX. I hope you
X.
remember. Yes, you. I hope these all things you are remembering. These all things we have discussed in our organic chemistry chapters, right? So Grignard reagent. So what has been done? The whatever the magnesium metal is obtained, it is converted into its Grignard reagent. That is your RMGX, which is your organometallic reagent. The number of moles of the Grignard reagent obtained is. So after passing the electric current into the fused anhydrous magnesium chloride, the magnesium metal, okay, whatever it is obtained, it is converted into a Grignard reagent. So they have asked how many number of moles of Grignard reagent is obtained. Okay. So here, so the number of moles of the Grignard reagent obtained is, okay. So here we are going to use the formula. So that is W is equals to Z into I into T. Okay. So here what is Z? Z is your equivalent weight. Okay. Z is your equivalent weight. T is the time taken. Okay. So let us see here where Z is equals to your equivalent weight. How you are going to calculate the equivalent weight? So here what all is given here? Your electric current, okay, 9.65 coulombs. Okay, that is your 9.65 coulombs is given. Then your so W weight is equals to I into T. So equivalent, so I into T. So that is your how much electric current is passed. Okay. So electric current into the time. So that is your I into T. So this is your I into T, that is 9.65 coulombs. So this much is the coulombs of at that particular time it is passed. So it is 9.65. Now we have to calculate Z. Okay. Z is equivalent weight upon the Faraday. Now equivalent weight of your magnesium metal. Okay. So it is 12 by 96,500. 12 by 96,500, that is your Faraday. So if we calculate these, so W is equals to Z is your 12 by 96,500. Okay, Faraday, you're multiplying it by Faraday, then into your 9.65. So how much you're going to get? How much you're going to get the work done? So it will be 12 divided by 96,500 into 9.65, that is 0.0012. Okay, now Mg plus 2. So magnesium chloride is converted into magnesium metal. Okay, so Mg is, so how many grams of Mg is converted into that, you have to check now. 24, right? So Mg atomic weight is 24. So 24 grams of Mg plus 2, okay, is nothing but your 1 mole of Mg. Okay, it is 1 mole of Mg. Okay, so 24 gram is the atomic weight of the magnesium chloride. So magnesium chloride that represents your 1 mole of Mg plus 2. So 12 into 10 raised to minus 4. 12 into 10 raised to minus 4. Or you can write it as 0. I have got it as what? 0.0012. Okay. So this much grams of Mg plus 2 we have. So how much mole it is? They have asked number of moles, right? So we have to cross multiply. So it is 24 into x is equals to 1 into 0.0012. So x is equals to 1 into 0.0012 divided by 24. See what is the answer you are getting? Simple calculation. Just cross multiplication. So for 24 grams of Mg plus 2, 1 mole, it represents 1 mole of Mg plus 2. So we have how much grams of Mg produced after the anhydrous magnesium chloride is passed by the current of 9.65, we get 0.0012 grams of Mg plus 2. So that represent how much mole. So you have to cross multiply. So it is okay. So we are going to get 1 into, so I'll just see the answer. Simple. Okay, so 1 into 0.0012 divided by 24. So it is 0.00005. That is 5 into 1, 2, 3, 4. 10 raised to minus 1, 2, 3, 4, 5. 10 raised to minus 5 moles. So it is 5 into 10 raised to minus 5. Option number C. Yes, Sanjeevni, baby, Lubna. Yes, have got it correct. It is option number C. Option number C. Okay. So how much weight of that is the number of moles of Grignard reagent produces 5 into 10 raised to minus 5. Okay, I hope this is clear. Let us go for the next question. The standard EMF of galvanic cell involving 3 moles of electrons in its redox reaction is 0.59 volts. The equilibrium constant for the reaction of the cell is A 10 raised to 25, B 10 raised to 20, C 10 raised to 15, and D 10 raised to 30. Okay, so here we have to use the standard equilibrium constant. Okay, so the formula is what? NF E naught of cell is equals to 2.303 RT log of K. So please know what are the important formula which all are involved, okay, in this chapter, so that you have to make a note. Nernst equation, okay, equilibrium constant, how to calculate the EMF of the cell. So these are all the important. So equilibrium constant for the cell of the reaction is given as N E naught of cell, okay, 2.303 RT log of K. So E naught of cell. So E naught of cell is equals to 2.303 RT NF, okay, into log of K. Okay. So you can also write this as 0.0591 N log of K. Right. So now what is N? N is our, how many number of moles of electrons are involved? 3. So N is 3 here. So put the value of 3. So log of K, okay, log of K is equals to 0.59 into 3 divided by 0.0. So just see, calculate and see what is log of K. So we have to calculate the equilibrium constant. Okay. So put the values. So after solving this, what you're getting, just see what is the answer you're getting. Simple calculation. So we are finding the log of K. So 0.59 divided into 3 divided by 0.0591. 29.9. Okay, that is your log of K. Now you have to take anti-log. So anti-log of this 29.9. It will be 10 raised to 30. If you find out the answer, anti-log of this, okay, you are going to get 10 raised to 30. That is, yes. Shri Varuni, Sanjeevni, Lubna, yes, very good. It is 10 raised to 30. Option number D. Okay, so very simple question. So similarly, like this standard EMF of the galvanic cell will be given. Okay, the number of moles might be different. They might give you 2, 5 like that. So different number of moles will be given. Okay, and the EMF of the cell is also given 0.59 volts. Then you have to calculate the equilibrium constant. So remember this formula. Okay, this particular formula, that is NF E naught of cell is equals to 2.303 RT log of K. So E naught of cell is given. So E naught of cell is given, N we know, R we know, okay, standard temperature, time we know. So after putting this all values, okay, we are going to find the log of K. Then log of K, K is, we are going to get the log of K, and then we have to find the anti-log. Okay, after putting the anti-log, we are going to get 10 raised to 30. I hope you know how to find the anti-log in the...
Your voice is not clear.
Okay. I hope you know how to calculate the anti-log. Okay, so practice how to find the anti-log on log tables. Okay, in the log tables, how to find the anti-log, you have to know it very well. Okay, fine. Next question. The EMF of a galvanic cell constituted with the electrodes Zn plus 2, okay, Zn plus 2 zinc, the cell of the EMF cell is 0.76 volts, and Fe plus 2 in Fe The E naught of this is minus 0.41 volts E. So what is the EMF? So calculate the EMF. Simple question. Okay. EMF of the cell. So half cells are given. Find out. Find out. I'll give the formula. E naught of cell is equals to E cathode minus E anode. Or E reduction. Yes, what answer you're getting?
Option A, ma'am.
Option A. Okay. Others?
Option C, ma'am.
Option C. Okay, Sanjeevni, you're okay. Sanjeevni have got it as C. Lubna has answered as A. Baby has answered as A. Simple E cell. How to calculate E cell? E cell is equals to E right hand electrode minus E left hand electrode. Cathode minus anode. Right. Then E naught of cell. Minus 0.41 volts minus of minus 0.76 volts. So it is minus 0.41 plus 0.76 volts. It will be plus 0.35 volts. Okay, so option number C. Option number C. So who all have answered option number C? Yes, Sri Varuni, Baby Sanjeevni. Yes, option number C is the correct answer. Okay. So plus 0.35 volts. Plus 0. So EMF of cell. Okay, EMF of cell. It is given by the E cathode minus E anode. Okay. So you have to write the cell reaction for this and then represent the. So based on the electrode potential values, okay, E cathode minus E anode. So E naught of cell can be calculated and you will get the EMF of the cell. So option number C is the answer. Okay, next question. Impure copper containing Fe, okay, silver, gold, silver as impurities is electrolytically refined. A current of 140 ampere for 482.5 seconds decreased the mass of anode by 22.26 grams and increased the mass of cathode by 22.011 gram. Percentage of iron in impure copper is. So give molar mass of Fe is given 55.5 grams per mole. Molar mass of copper is given 63.54 grams per mole. Okay. So how you are going to solve this type of question now? So your what is given? Impure copper is there, and that impure copper it is containing your Fe. Other metals are also present. Okay, that like iron, gold, silver is present, and these are impurities. So it is refined. Refined means what? The pure copper is extracted from this process. Okay, by refining process. Now, what is done to that? A current is passed. A current of how many? Of 140 ampere is passed for 482.5 seconds. After passing the current, okay, of 140 ampere for 482.5 seconds, the mass of the anode is decreased by 22.26 grams and the mass of the cathode is increased by 22.011 gram. So they want to know the percentage of iron in impure copper is. What is the percentage of the iron in impure copper? So how much percentage of iron is present? Okay, in that copper, impure copper. Now here, what is happening to copper? Copper plus 2 electrons. Okay, it is getting what? Copper is getting reduced, right? So it is, there is a gain of electrons. So copper, so what, first we'll find the equivalent weight. Equivalent weight of copper is how much? So it is, copper weight is 63, how much it is? 63.54. Okay, and what is the given weight? It is 2. Okay, copper plus 2, so 2 electrons are involved, so 2. So 2, just find the equivalent weight. 63.54 divided by 2. So 31.77. Okay, 31.77. Now, this is for your copper. Now, Fe plus 2 electrons giving you Fe. Okay, so another, this is of your iron. So iron is also getting reduced. Now, what is the equivalent weight of this? Equivalent weight of the iron is 55.5 divided by 2. 2 electrons are involved. So it is 2 ones are, 2 twos are, 2s are, and 2 sevens are 22.75. Okay, so the equivalent weight of iron is 22.75. So what is happening to the mass? Mass is increased at cathode. Okay, mass is increased at cathode, and why it is increased? Because there is a deposition of copper. Okay, so there is a deposition of copper. So because of the deposition of copper, the mass at cathode is increased, and because of that, so what is the number of gram equivalent? Okay, so we have to calculate the how much gram equivalent of copper is deposited. Copper deposited. So the number of gram equivalent of copper deposited is 22.011 gram. Okay, divided by the equivalent weight of copper is 31.77. Just see how much you're getting. 22.0. 22.0119 divided by 31.77. It is 0.692. 0.692. Okay, now we let us use the Faraday's law, first law. Okay, so we are making use of the Faraday's first law. Now, by the formula of Faraday's first law, okay, so it is Q is equals to IT. Q is equals to IT. So how much is the current passed? It is 140 into time taken is 482.5 seconds. So just see how much current is passed. Yes, so it is 140 into 482.5. It is 67,550 coulombs. Okay, it is 67,550 coulombs is passed. So now, so 96,550 coulombs. Okay, if you pass this much, it will give you how much? It gives you 31.77 grams of copper. So this is a standard. Okay, so 96,550 coulombs, it will give you 31.577 grams of copper. So for your 67,550, okay, just now we got coulombs, how much it gives you? Okay, how much it gives you? So cross multiply, so it will be 96,550 into x is equals to 31.77 into 67,550. X is equals to 31.77 into 67,550 divided by 96,550. Just see how much you are going to get. Find out. Find out. 31.77 into 67,550 divided by 96,550. So I got 22.227. Okay. So 22.227 grams of pure copper. So, but here what how much is increased? It is increased by 22.011. But by our this, okay, the mass of the cathode increases by 22.011 grams. So let us subtract it. So this is what 22 point, take the proper value. It is 22.31.77 into 67, 50, it will be 22.227. Okay, so 22.227 minus 22.011. So how much is the real difference? 22.227 minus 22.011. It is 0.216 grams. Okay. So, so here 31.77 grams of copper, it is approximately 0.217 grams of deposited. Okay. So for 27.75 grams of Fe, so how much it will be? So 0.228 divided by 31.77 into 27.75. So the reduced iron is 0.199, okay, grams of Fe deposited. So this is the amount of Fe deposited. Okay, now if you remove the percentage, how much is how much it is removed, percentage, we have to find the percentage of iron. Okay, now percentage of iron is what? Mass of the iron divided by the mass of impurity. Okay, how much mass of impurity is present into 100. So the mass divided by what is the mass of impurity? 22.26. 22.26 into 100. Okay, so it will be approx, how much it will be? Just see, 0. Little tedious it is, 22.26 into 100. So I got 89.3. 89.3 means approximately 0.90. So option number D. Okay, option number D. So little, yes. Okay, so it is option number D. So what we have done here, so in they are doing refining. Okay, they have done the refining of an electrode. Okay, impure copper is there. In that impure copper, they are going to separate what? They are going to separate, they want to find out the different impurities. Okay, iron is there, gold is there, silver is there. So these are electrolytically refined. They are separated, okay, from the impure copper. Now, after passing a current of 140 ampere, okay, for 82 seconds, okay, what is happening? The mass of the anode is decreased, okay, and the mass of the cathode is increased by some grams, okay. From that, they want to find out the percentage of iron. How much percentage of iron is there in that impure copper? So by taking the equivalent masses, so first we have found out the equivalent masses, okay, how much the copper is deposited. And from that, then we have found out, we have subtracted the amount of iron obtained. And then we have from the total impurity, whatever the mass of impurity is decreased. Okay, so we have subtracted it, and then we have found out the percentage of iron in that impure copper. So this is a bit tedious question, okay, but you have to go stepwise. So okay, we have to use the stepwise method. So we got the percentage of iron in that impure copper is 0.90. Okay, fine. Let us go for the next question. For hydrogen oxygen fuel cell at 1 atmospheric 1 atm, okay, atmospheric pressure and 298 Kelvin, H2 gas plus half O2 gas giving you H2O water, the delta G naught is equals to minus 240 kilojoules. So E naught for the cell is approximately. So what is the E naught of the cell? Yes. So for the hydrogen oxygen fuel cell, so for calculating the hydrogen oxygen fuel cell at 1 atmospheric pressure and 298, so standard conditions are given. You have to calculate the E naught of the cell. Okay, you have to calculate the E naught of the cell. So the delta G naught is equals to minus N F E naught. Okay, so calculate, put the values. So delta G naught is given as minus 240. Minus 240 kilojoules. If I remove kilojoules, it will be 2000, 1, 2, 3, 4. Okay, kilojoules. Okay, into 10 raised to 3. So it will be 1, 2, 3, 4. So is equals to number of this involved is how many? N. N is the number of electrons involved. Okay, the number of moles, it is 2. So it is minus 2 into Faraday is 96,500 into E naught of cell. E naught of cell, you have to calculate E naught of cell. So E naught of cell is equals to. So just see how much you're going to get. Minus 2 into 96,500 divided by. Yes, how much you're getting? Just see. 96,500 into minus 2. E naught, I am getting as 1.24 volts. Yes, others 1.24. Yes, Sri Varuni has got. Baby has also got. Sanjeevni has also got. Yes, it is 1.24 volts. Okay. So E naught of the cell approximately is 1.24 volts. Okay. Fine. So please remember the this. Okay. Formulas. So how many coulombs of electricity are required for the oxidation of 1 mole of water to dioxygen? How many coulombs of electricity is required for the oxidation of 1 mole of water to dioxygen? H2O. Okay, so what is happening here? For the oxidation means there is a loss of electron or water 2H plus half O2 plus 2 electrons. So there is oxidation of 1 mole of water to dioxygen. Dioxygen means half O2. Okay, so water is here. So how many coulombs of electricity is required for this oxidation? So here how many electrons are involved? 2 electrons are involved, right? So coulombs of electricity. So coulombs of electricity required for the oxidation of 1 mole of water to dioxygen is how many? 2. So 2 moles of electrons are involved. So 2 into your Faraday's value is 96,500. So it is how much? How many coulombs of electricity is passed? You have to multiply it by the Faraday. 1 Faraday, that is 96,500 into number of electrons involved. How many? It is 2. So how much you're going to get? Just see. So 2 into 96,500 is 193,000. Okay, so this much coulomb, which is equal to 93.9 1.93 1.93 1.93 into 10 raised to minus 10 raised to 5 coulombs. Okay, 1, 2, 3, 4, 5. So 1.93 into 10 raised to 5 coulombs. So it is what? Option number A. Option number 1.9, sorry, option number D. Okay, 1.93 into 10 raised to 5. Yes, option number D. Okay. Others have got, yes. So how many coulombs of electricity is required for the oxidation? Oxidation means how many electrons are involved. So there are 2 electrons involved. So what we are doing here, so electricity of this will be calculated by how much? So into we have to multiply the number of moles of electrons into the Faraday. Okay, that is 96,500. So we got 1.93 into 10 raised to 5 coulombs. So that much amount of coulombs of electricity is passed. Okay, so option number D. Is it clear? So we have seen some 10 questions. Okay, so we are going to solve some more questions in the next step. I hope today's questions are clear. Yes. Fine. So, some more questions. Okay. So, these are the type of questions which will come from this particular chapter. So, similar questions. Okay. Uh, we are going to solve on this chapter in the next class. I hope you have understood. Yes. Fine. So, by this, yes, okay, fine. So by this, I'll end the session here. If you find some more questions, okay, please solve related questions. It will be a practice for you also. Okay, so try to solve such questions. So it will help you to understand the concepts more clearer and go through the ACE sessions again. Okay, so that it will be a revision for you. You'll revise the session again. Okay, you'll understand the concepts clearly. Okay, fine. So by this, I'll end the session here. We'll meet in the next class. Thank you.